Advanced Algebra Concept Exam Review. We're going to look at concepts 11 through 15 today. This is problem number 1, and all they want to know is what's the vertex of the function. We'd need to be able to find the vertex in order to graph. I like to use a method where I basically write this in a certain form and then I can just look at it and tell where the vertex is. And that form requires a positive 1 to be right here. And I see a positive 2. So let's go ahead and factor that 2 out. That'll leave me x minus 5 halves. Notice if I redistribute the 2, I'd get my 2x back and I'd get my negative 5 back. So my factorization is correct. Once I've done this, now I can see the vertex. The vertex is at the opposite of negative 5 halves, in other words, positive 5 halves, comma, negative 5. So my x value appears inside here and my y value out here. Always remember to use the opposite value of what you see inside the absolute values for your x value after you have 1 in front of the x. If I want to check my work, I could pick up my calculator and open the scratch pad and graph this function. Just say f1 or whatever function I have available. f1 of x is equal to the absolute value of 2x minus 5 and then minus 5. And then go ahead and use the analyzer and find the minimum value of the graph, because the minimum value would give me the lowest point, and in this case this parabola opens up, so its lowest point would be the vertex. And note that the vertex is 2.5, which is the same as 5 halves, comma, negative 5. So I've got this problem worked and checked, so my final answer is my vertex is at 5 halves, comma, negative 5. Alright, number 2 asks us just to graph a function. We're going to graph y equals negative absolute value of x minus 2. In order to do this, I need to identify where the vertex is. My vertex is going to be at 2. It's the opposite of negative 2 is positive 2, comma. There's nothing out here, so we're not going to move it up or down. It's just 2, comma 0. Let's go ahead and plot where that point would be. 2, comma 0 is right here. Notice the scale is going by 2s, 2, 4, 6, 8. And it's going to open down because of the negative in front. So if we go down 1, we're going to go over 1. If we're going to go down 1, we're going to go over 1. Same thing on the other side. And now we can just go ahead and grab a straight edge and plot this line. And the other half of my absolute value graph. So there's my V. If I want to check my answer, I can go ahead and just pick up the calculator and get into Scratchpad and graph absolute value of negative x minus 2. Notice that it has the same vertex. That vertex in this case is a maximum value because it's the highest point on the graph, and the same angle on the sides, the same slope of the sides. The point here at 0, 2 looks the same in the graph, so it's pretty good. I'm pretty happy with my graph. It looks exactly like what the calculator would have done, so I've got a good graph and a good check. Number 3 is another graph the function question. I recognize it as a absolute value, so it should get that nice V shape again. The vertex is going to be at 5, comma 2. Remember the opposite of inside, comma the outside, so 5, comma 2. So let's go find 5, 2. Here's 5. 2 is right here. The graph's going to open up and the slope of the sides is 1, so it's going to go up 1 over 1. And we'll go ahead and grab a straight edge and graph this. And if we want to, we can check it real quick just by picking up Scratchpad and looking at a graph. Notice the vertex matches and the intercepts. Oh boy, did I not match. I'm glad I checked that one. I should have gone to 5, negative 2. And here's the negative value right here that I didn't pick up the first time. This is why you check your answers. You check your answers to make sure you don't make silly mistakes like I just did. So let's go ahead and clean up this. We'll replot this at 5, -2. So we'll go to 5 and to -2 this time. And the slope is still 1 on the sides. Let's clean up that little mess. Notice how this is going to have an x-intercept at 3 as this does, and hopefully the y-intercept works out for us too. So it's got an x-intercept at 7 as we see here, and it's got a y-intercept at 3. 1, 2, 3, we see that here. So it's a good thing I checked that. I would have got that wrong if I hadn't checked it. Always, always, always check. Every now and then you're going to make little mistakes. And it's a lot of times it's just a little minus sign that you mess up. Alright, in this problem we're asked to solve the system. And we've learned recently that the easiest, most efficient way to solve systems is with matrices. So all I'm going to do is I'm going to go ahead and pick up my calculator, go right to the scratch pad and put this in as a matrix. And I'll get the answers right here in my answer matrix. So this is telling me that x is -5 and y is 0. The answers are found in this last column over here. The x value is -5 and the y value is 0. Why? Well, because this is my x column in the matrix. Notice the 4 and the 3 are in this first column. This is my y column in the matrix. Notice the 2 and the -7 are in the second column. So I've got an x value. 1x is the same as -5 and 1y is the same as 0. So my solution there is -5, 0. Alright, this problem's number 5 is a lot like the last one, except they don't give me the equations. I have to figure them out. So let's read through here and see what we can find. We've got 44 people attend a ball game. There are 3 times as many children as adults in the group. Set up a system of equations that represent the number of children or adults and children who attended the game and solve. So I need to set up a system of equations. I need to solve it to find the number of children who are in the group. I'm going to let A equal the number of adults and C equal the number of children. There are 44 people, so that means that A plus C has to equal 44. The number of adults plus the number of kids is 44. It says there are 3 times as many children as adults. Let's work over here. I want the number of children to equal the number of adults. And I already know there's 3 times as many children as adults. So if I multiply the number of adults by 3, that should bring them up to equal. So if there were 10 adults, there'd be 30 children. 3 times 10 is 30. 30 equals 30. That works out. So the reason I brought that over here is because I want to make sure I have an A column, a C column, and a constant column after the equal sign. So I need to rewrite this. I need to bring the A over. So I got -3A plus C is equal to 0. -3A plus C is equal to 0. Now there are many ways I could do this problem, at least 3 or 4 that I can think of. If C equals 3, I could just use straight substitution. If I stack it up like I have here, I could use elimination. There's at least those ways, and I could also use the calculator. I think I'll use the calculator to check, and what the heck, let's go ahead and just do C equals 3A here and just do substitution. So if C is the same as 3A, then this original equation A plus C should be able to be written as A plus 3A, and that equals 44. A plus 3A is 4A's. 4A's equals 44, so A is 11. If there are 11 adults and there are 3 times as many children, there would be 33 children. Now recall when I had this equation back here written as, let's see, -3A plus C equals 0. If If I wanted to, I could put that into a matrix and RREF that and find out that there would be 11 adults and 33 children. So I'm going to use that as a check. I've already done the work here and found out that there are 33 children. I'm just going to use the matrix as a check in this case. So I have 33 children for my final answer. And it's been checked. It's good. I know this one's going to be right. Alright, number 6 asks us to solve the system of inequalities. And when they ask us to do this in this format, they really just mean graph the system, show a solution via a graph. So let's go ahead and graph. This first equation is set up in slope-intercept form. They're telling me that the intercept is 1, so I know it's going to go through positive 1. And it has a slope of negative 1, which means it's going to fall 1 and run 1. And I noticed that it's or equal here, so I'm going to get a solid line graph. So let's go ahead and graph this line. And extend it the other way too. Now it says that it's less than or equal to, so we're going to be shading on one side or the other. If I try 0, 0, 0 is less than 1 is true, so this is the true side. And I need to go graph the other line. It has a y-intercept of -3 and a slope of 4, so that means it's going to rise 4 and run 1. So let's let it rise 4. We're at -3. There's 4, run 1. It put us here. Let's do that again. Rise 4, 1, 2, 3, 4, run 1, and put us here. Alright, so let's go ahead and graph that line. But this line is supposed to be dashed because it's strictly greater than. So we'll draw a dashed line here. And extend that the other way if possible here. Something like that. And we need to figure out which side to graph. It says y is greater than. Let's try a test point 0, 0. 0 is greater than -3 is true. So we are going to be shading on this side. And we just need to go ahead and shade that in. So our final answer would be the shaded region over here. That should do it for us. Okay. If we wanted to, we could, again, pick up the calculator and do a check. And if we did that, we would see a graph that looks like this. Notice that we have the solid line and the dashed line that does appear in the graph, solid and dashed. And also notice that the final overlap is this region out here to the left, where we found the overlap in our graph too. So the final shaded area there. Alright, question 7 gives us an exam that consists of 2 parts. We have an X section and a Y section. There can be a maximum of 85 questions, maximum. There must be at least 5 more questions in the Y section than the X section. We're asked to do a couple of things. Write a system of inequalities to model the number of questions in the 2 sections, and then just graph it. Notice it doesn't ask us to solve anything. It just wants to see if we can write the system and graph it. So let's start working on that system. There are some X questions and there are some Y questions, and there can be a maximum of 85. That sounds like X plus Y must be less than or equal to 85. There must be at least 5 more questions in the Y section than the X section. So Y has to be greater than or equal to, that's at least X plus 5. And then X has to be greater than or equal to 0. We can't have a negative number of questions, and Y must be greater than or equal to 0. We can't have a negative number of questions. So this group of information right here will take care of that first request, which was write a system of equations or inequalities to model the situation. Notice it says inequalities and I don't have any equal signs, so I've got all inequalities. That's one thing. Make sure you write the kinds of equations, inequalities that they ask for. Now we just need to go ahead and plot. And I noticed that my y scale isn't quite up to snuff here. It's only going by ones. So let's just go ahead and off to the side here say that this is by 10 times 10, so that we can actually plot x plus y is less than or equal to 85. If I'm going to plot x plus y is equal to 85, I need to ask myself to find a couple points here. So let's just find a couple points. If x is 0, wouldn't y have to be 85 to be equal? Yes. When you're finding points, you're looking for the boundary line where equality happens. So I don't worry about less than, I'm just worrying about equals. When y is 0, x would also have to be 85. So that gives me a couple points. One at 85, 0, 85, and one at 85, 0. Remember, I've gone ahead and multiplied this by 10, so 8 is really 80 and 9 is really 90. And this should be a solid line, so let's go ahead and get this solid line back. And we'll draw that line here from here to there. Recall that x greater than or equal to 0 and y greater than or equal to 0 forces me to the first quadrant. So I don't need to worry about anything going on past the x or y axis out of the first quadrant here. It says that x plus y is less than or equal to 85, so that means we're going to be shading on this side of this graph. And now I need to go find points for the other graph. Let's go ahead and change colors out and work on points for the other line here, x and y. If x is 0, for y to be equal, it would have to be 5. And if y is 0, x would have to be negative 5. Well, negative 5 is going to be hard to graph, so let's find another point. If x was, let's say 50. If x was 50, then 50 plus 5 would be 55, y would be 55. So let's plot these 2 points, 0, 5, and, oops, if x was 50, let's turn that around so it's right. If x was 50, y would have to be 55. Let's graph 0, 5 and 50, 55. So 0, 5, if that's 10, 5 is going to be halfway or about right here. And 50, 55 should be about right halfway between the 5 and the 6, which represent 50 and 60. So let's go ahead and draw that line. And there we go. It looks like we have an intersection point at 40, 45. And if we plug that in, 40, 45 works in this equation, and 40, 45 works in this equation. So that indeed is the intersection. It's at 40, 45. We weren't asked for that, but since it came out so nice in our graph, let's go ahead and label it. We still got to do shading on this. It says y is greater than or equal to x plus 5. Well, if I try 0, 0, 0 is greater than 5 is false, so it's got to be true on the other side of 0, 0. So it's true on this side up here. And so my shading would be this triangular region to the left. Let's go ahead and shade that in. This region to the left. And there we go. Again, if I want to check this, I can put this into the TI Inspire and take a look. And notice that the Inspire came up with the same graph that we have. Little different scaling because it's wider than it is tall for the same 100 tick marks here as we have on the vertical scale, but it is showing the same result. Alright, this is our last problem on the exam. We're asked to graph the system of constraints that's already given and then find the values of x and y that maximize p equals 40x plus 30y. So let's go ahead and graph. X is greater than or equal to 0 and y is greater than or equal to 0. Just forces us to the first quadrant. So that's done. The next equation, negative x plus y is less than or equal to 4 would, let's go ahead and rewrite that as y is less than or equal to, add the x to the other side, x plus 4, and graph it that way. So 4 would be my intercept right here. And it has a slope of 1, so up 1 over 1, all the way through these values. And let's go ahead and plot that line. And then we need to determine which side that would shade on. If I put in 0, 0, it's true, so we want to shade the 0, 0 side. So it would be below here. So it would be shading below. And I only have one more line, that's x is less than or equal to 3. Well, we know that's going to be right through the x-axis and be vertical, so it's going to go straight up and down on x equals 3. And we need to figure out which side. Well, x is less than 3, so we're going to be shading on the left side here. Values that are less than x. And we can quickly see that the overlap happens in this area. So everything in the, oops, missed the tool. Everything in the first quadrant where we have this shape. All right. In order to answer the next part of the question, we're going to need the intersection point up there. So let's go ahead and see if we can find that, this point right here. It looks like it might be 3, 7. It's pretty close to 3, 7, so let's check that. Is 3, 7 works in this equation. If x is 3, is y 7? Yes, it is. So that is the point 3, 7. And let's go ahead and label the other points on around here. This is the point 3, 0. This is the point 0, 0. And this is the point 0, 4. Alright, so we've done the first part. We've graphed the system of constraints. Now we need to find the values of x and y that maximize the function there. So let's go ahead and try that out. So p is equal to 40x plus 30y. So the first value here is 0, 0, and then head on around. We have 0, 4, 3, 7, and 3, 0. Let's see if we can eliminate some of these to make our work less. Notice that I'm putting it into a function where everything's positive. So 4 being bigger than 0 and the 0 is tied, I'd get a larger value from 0, 4 than I would from 0, 0. 7 is bigger than 4 and 3 is bigger than 0, so I'd get a larger value from 3, 7. The 3's are the same and 7's larger than 0, so I'm going to get a larger value from 3, 7. Again, I was asked to maximize, that's why I'm looking for larger values. So if I put in 3 and 7, I'd have 40 times 3 plus 30 times 7. The result there is 330. So I get a maximum value when x equals 3 and y equals 7. Those are the values of x and y that maximize the function p. That's it.